We now return to the practical guide to the universe on the Learning Channel. Stars may develop singly, like our sun, or in systems of 2, 3, or even more. The more stars in a system, the more complex their interactions. For instance, 2 stars may orbit each other, and then the 2 together orbit a third. Imagine what life would be like on a planet in such a system with 2 or 3 suns in the sky. Darkness would be a rarity. The times of warmth and cold that we call summer and winter might not follow at annual patterns at all. Our world would be a much different place. In binary or 2-star systems, one star as it gets old and becomes a red giant may lose mass to its companion. If its companion can't absorb it, a violent explosion may occur, what is called a supernova. The most curious object of all in the galaxy is an awesome phenomenon called a black hole. In the Cygnus X1 star system, matter from a visible star is spiraling towards an invisible object like water running out of a bathtub. The spiral is so hot, it produces X-rays, a telltale sign of a black hole. Black holes are one of the strangest predictions of Einstein's theories. They're produced when a star collapses to the point where its gravity overpowers the strong nuclear force found in the nucleus of atoms. When that happens, the force of gravity pulls the star in upon itself until it disappears altogether. The matter of the star is gone. All that remains is its intense gravity. Even light can't escape from it. In fact, there may very well be a gigantic black hole at the center of our galaxy.
There are certainly evidence that there are black holes at the centers of some galaxies, and there's some indications even that there may be black holes at the centers of most galaxies. The evidence for a black hole at the center of our own galaxy is not extremely strong, but there's certainly possibilities. The fact that we see gamma radiation, particularly annihilation radiation, coming from matter-antimatter annihilation toward the center of our own galaxy, is an indication that something out there in that direction is producing vast quantities of antimatter, and a black hole seems to be a very good candidate for that sort of thing.
We tend to focus a lot on our galaxy, but there are billions just like it in the universe, and billions more that are different in structure. In the large view of cosmology, galaxies can be said to be very similar to atoms, because atoms can attract one another and form a molecule. The same is true of stars and galaxies. Dust clouds attract each other and form stars and planets. These collect in large groups and form galaxies. When galaxies cluster together in space, they're called groups.
We don't know for sure why most galaxies are in groups, and a certain substantial fraction of galaxies are in the much more prominent formations we call clusters of galaxies. But the assumption is that whatever caused galaxies to form also caused groups and clusters of galaxies to form. That is, that there was something in that part of space, way back when, not long after the Big Bang, that caused stuff to accumulate in those regions of space and not in nearby regions. So that you have places where there are lots of galaxies, and then you have these gigantic voids where there appears to be almost nothing.
Our local group of galaxies is about 5 million light-years in diameter. It has around 20 galaxies, which represent several of the main galactic types. Only 2 others are spiral galaxies like our own. Most are spherical, and at least one is an elliptical galaxy. The nearest spiral galaxy is 2.3 million light-years away, the Andromeda Galaxy. Like ours, it is surrounded by groups of stars known as globular clusters. Our group of galaxies is part of a much larger group called a supercluster. It stretches an astonishing 100 million light-years in diameter. This particular supercluster contains our modest local group, the much larger Virgo cluster, and many other groups of galaxies. On an even larger scale, scientists have recently discovered that superclusters also form in groups. They are distributed throughout the universe in long, open filaments. In between are voids and pockets of nearly empty space. What could explain this apparent order? No one knows for sure, but the discovery has challenged our long-held theories about the origin of the universe. In the 1920s, astronomer Edwin Hubble focused on the light emanating from distant galaxies. When seen through a prism, it broke down into a rainbow of colors called the spectrum. Through his observations, he found that the light from these galaxies was shifted towards the red end of the spectrum. This shift, sometimes called the Doppler shift, is caused by movement of the light source toward or away from the observer. It's very important in astronomy for determining the movement of stars and galaxies. Sound also exhibits the Doppler effect. If a car drives by and blows its horn, the pitch of the horn changes. It's higher as the car approaches and lower as the car leaves. The frequency of the sound wave determines the pitch. Light behaves the same way. The light from an object, such as a star or galaxy, shifts to a higher frequency if it is moving toward us. It shifts toward the blue end of the spectrum. If it is moving away, it shifts toward a lower frequency, or the red end of the spectrum. Hubble's discovery was startling. It not only meant that distant galaxies were moving away from us, they appeared to be flying away from each other. Scientists quickly understood that if all of the galaxies are flying away from one another, then at some time in the past they must have been all in one place. And from there,
as far as we know, the universe began with what's called the Big Bang, a massive explosion which created essentially everything that we know today in the universe. And the universe has since expanded and continues to expand today. The structures which we see in the universe are remnants, relics of the original explosion, and the developments that have taken place since then have given us an idea of how that original explosion took place and what has happened since then. We'll return to the Practical Guide to the Universe on the Learning Channel.